So recall earlier when we were talking about creating nonlinear transformations of the inputs. So you can think of these as, for example, our MNIST data set where we had up to 256 different grayscale values here. And we said we could manufacture possibly other features that are dependent on these features, the input features, in a way to make it useful for classification. So we talked about two particular ways of doing that. One was, for example, calculating an intensity score. So how could we calculate an intensity score through a neural network? Well, that would just be dependent on perhaps summing together all of these values, right? 1 through 256 values and aggregating that in an upper level node, and that could be our intensity. But we also had another type of node that we could calculate, that was symmetry. And how could we calculate symmetry? Is it something we could do at just a single level computation? Well, not very easily, so let's try to compose it through several different parts. If we imagine that this part of the network is the left half and this half the right half, then we could compute this in two separate nodes. For example, what we could do is we could aggregate the left part of the network in a node over here and the right part of the network in a node over here. For example, setting certain edges to have 0 weight so that this gets a sum of the right part of the network and a sum of the left part of the network. And then at an upper level node, calculate symmetry by taking the difference between these two in some way. So this could be learned by a neural network by itself, actually not engineering these directly, but trying to learn them through stochastic gradient descent by first doing the propagation forward in our feed forward and doing the back propagation in the back. So this has a very nice, appealing idea, which is that we don't have to engineer the features by ourselves. We don't have to make the nonlinear transformation. We can learn these nonlinear transformation, learn useful features in hidden layers so that we can use those for the final creation of the hypothesis at an upper layer.